So today I'd like to take the opportunity to discuss cybernetics on the beam, um, which is somewhat of an interesting topic for not only myself, but I think it might be interesting for other people as well, because I believe that the way that the beam is designed is to actually complement the process of cybernetics, which in itself is something somewhat bizarre. Um, that sort of targets an aspect of not only thought but implementation, that I think that is very common within some of the patterns that we see within programs that actually utilize the beam for most, and if not um, most of their general operations. So this would be the general topic and ethos that I wish to discuss today. So cybernetics is a somewhat controversial topic, basically based on its origins, and not only that, the way in which some of the experimentation might have taken place. Due to the time and nature, I personally believe that it might have been just due to the procedures not being in place at a particular time. You know, so yeah, you lace one or two people, or at least you lace a group of people at a party with LSD. Does that make it a bad thing? Probably not. But then you use strobe lights to then, um, to attempt to see how that alters the effect and things of that nature, which can be rather controversial and really bad. But again, I think at the time it was definitely viewed in a not so drastic light. Whether or not people were aware of this or not is unclear. But I think those are some of the processes that people definitely had issues with, and you'll find conspiracy theories on the internet about this and about these sort of time periods around ideally the 1960s to about the 80s, I guess, where this sort of experimentation might have been taking place. But the notion around it, personally, I believe is it's somewhat just unsettled, just simply because of the procedures at the time may not have been in place to appropriately um, have the right procedures. But again, it underpins quite a lot of different things, and also some of the animal testing processes are something that's frowned upon nowadays. But back then it was something that was actually quite common, and not that much of a major issue. But then again, we should also not be limited into thinking that it was only about human testing and things of that nature. Cybernetics itself underpinned a lot of different aspects, not only within psychology but also within it merged a lot of different fields in order to understand how best to achieve particular tasks, mainly around the um, shepherding of aspects of humanity in one notion or another. So it shouldn't really be majorly frowned upon, but I think like everything else, we should just take it with a pinch of salt and understand the context of the times, the political ethos at the time, when looking at some of the the psychological aspects around it. But it merges different fields together into one in order to achieve a singular goal. So cybernetics is the notion of control and communication inherently within machines. So it's the idea of designing machines to be able to control them appropriately, to be able to get the most value from them. It originated around the World War period of time. Some would say it originated originally in the UK, and then it was expanded upon in other regions of the world, mainly in America. However, I think that can be left to general, historic analysis and things of that nature. But the idea around it, basically, it's about cyber, right? It's about the cyber space, in essence, right? That's what it was mainly geared towards. But it was that at a time period wherein the wherein that aspect of things wasn't fully developed, or the idea around the cyberspace wasn't fully in fruition. So basically, that's what personally my understanding of it is. And I think, if you look at those records, if you look at those things that are there, you actually find that it goes even further than the stage that we're at today, right? It's really in depth, but the technology and things just wasn't available at the time to fully express what it is that was being intended. So because you will find like drastic technology, especially around the psychometric aspect of things, the psychology aspect of things. There's a lot of stuff, um, but also the psychological technology aspect of it as well. You'll find a lot of stuff there, and also there's a lot of research and things being done around it, especially around MIT, MIT. You find most of the research geared towards that environment. And basically, it's about just developing systems that meet a particular function or requirement, that's similar to what's capable in our day, in a sense of, or what's capable within human workflow and thought flow. So that's cybernetics as a whole. A lot of information around it, and it's way ahead of its time, even for today, from my perspective of things, anyway, from my understanding of things. So so that's cybernetics in a nutshell. And I think that you know Erlang as a functional language provides the necessary capabilities to support the cybernetic workflow. So, you know, I believe most people are familiar with Erlang, but the Beam itself, is a virtual machine that has multiple different languages on it. But one of the most prominent ones, from my understanding, is Erlang, which has a drastic history and not so pretty syntax, but functional and effective in a sense. And I think that the interfaces that are provided by Erlang, especially from a functional perspective, are quite impressive in relation to mapping out the concepts or ideas around the cybernetic notion of thinking into actual code, right? So this is one of the things. I'm not really a prominent Erlang developer. I don't have the greatest experience in it, but I always wondered as to how complicated can a process be, because the way in which we handle errors in Erlang, the way in which we manage things such as receives, the way we handle messages, so a process has a mailbox, and the mailbox has the ability to receive particular information from other processes, and then once that information is received, it's pattern matched, and then it's dealt with accordingly with particular functions. But how complicated can we actually make that? Those functions, in a sense, is one thing I always wondered, and also including the error handling process. It seems quite suitable in a sense, because the error can cascade up to the root process, in a sense, in one aspect or another. But I think not only that, the development structure, the syntax, and just the way that it's organized in general, I believe that it's highly powerful in taking thought processes ideas and concepts and putting them into code, right? And depending on how complicated we can make a process, I think very powerful things can surmount out of that. And I think also that the way that the methodology of just what's available in terms of, for example, strings being just lists, that's a powerful concept in itself because it enables you to analyze things very differently. The way that the binary structure syntaxes, the binary syntax can be evaluated and defined, etc. Those are all really powerful things within Erlang that I feel provide the ability to take thought processes or to take thoughts and concepts and put them into effective code, and the way that it's just functional and sequential is a powerful methodology. I think that is and the pattern matching as well really provides the ability to really formalize things into code. And then we have OTP, which is a set of APIs which actually enable process-oriented development, right? So OTP really enables us to think of things really differently. So sometimes I just look at it and I'm like, if we ever imagine a neuron, right? Neurons and synapses, that's very much the same way that we have, or the same capabilities that are provided to us by OTP, but we can never, mimic the brain in one sense or another. Because it's highly complex, and and you need a hell of a lot of processes for that, and a very complex system. But again, at the same time, I think that process-oriented development methodology enables us to effectively think about how to effectively design a system in line with cybernetic thought processes. And again, this goes back to the idea of how complex can we make a process in Erlang, and how that can interrupt with OTP. Because again, you don't want to complicate a process too much. But you want to be able to use generic servers and things of that nature in order to simplify the tasks. So in order to simplify the task, and so I'm probably just gonna go over 15 minutes a bit here, because again, at the same time, I think that because I'm doing a recording, I expanded things a bit, reduced the notes, and sort of just went over exactly what it is, like just to take the notion to actually just be fluid around my thought processes here. So besides only being highly available, which is very important, like, besides enabling high availability, I think that there's the notion that's normally underlooked around how it enables development in a different style to how most programs would do it. And I think that's one of the most powerful things about OTP, besides not only the high availability, but the way that it enables process-oriented development, right? So this is the idea of just taking a particular concept or idea and just putting it into code in a process, and then that process, and also isolating responsibilities within your code and structuring it in a particular way that's quite amazing and intuitive, and also having the ability to have different types of servers. So while I know that generic servers are some of the most common ones, there's so many within OTP, from my understanding, that it's actually beyond what we can understand, at least from what I can express at the moment. So for those that don't actually know, it's basically you address a particular function, you pass it in particular arguments, and the function is running itself as a process, and it has a set of supervisors, and the supervisors are organized in a particular supervision tree, and that supervision tree isolates errors, and you have the ability to link and monitor particular processes, just like how synapses and neurons would function, and you have that capability within OTP, utilizing Erlang to actually design and implement the logic that's necessary from a cybernetic perspective in relation to the things that you're actually trying to achieve. And also I think that it really gives the ability to separate different responsibilities between teams, and not only that, it gives the capability to be um, expressive and just isolate concerns as well. And I think that's a powerful thing. I can say so much about that, but I think that's a very, very powerful thing. But also it provides the notion of being highly available. And I believe you can also schedule processes to different nodes. Even you can correct me if I'm wrong on that. Which is key as well. So I think that's really awesome. And then we also have the systems thinking concept, right? Which is again cybernetics resurfacing, but in a different fashion, around sort of thinking about the system as a whole rather than decoupled parts. Um, which again I think that the concept of OTP provides, because while we want to separate concerns between teams and things of that nature, having a singular platform, having a singular code base around this is important, and is also amazing, um, to have that singular code base, but have those pieces decoupled in a sense, but having that notion of what's happening, and having a singular set of tools, a singular set of language sets to achieve a particular task, right? Which I think is important, um, overall, because I think that when it comes to designing systems of this nature, um, you know, like sometimes cybernetics can take the form of sometimes cybernetics can take the form of just simple things to achieve a particular process, and just having that those things sort of decoupled based on functionality is amazing. So I'm just trying to think of like something like, for example, like maybe a bike. um you have different components that come to be together to form the actual full-fledged thing. So having OTP and systems thinking in unison enables one to be able to say, this is the whole thing that I'm providing, whatever, be it an interface, an API, or whatever the case may be. But internally, you know this system is built on this platform, and that platform in itself has varying components that fit together pretty interestingly in order to provide that overall outcome. And I think that when we take cybernetics into heart here, into the Zoe processes, we then have an idea around like what applications that might be highly useful, and how to design those applications effectively, to reach that particular goal, and also the experimentation process, whatever it may be, is highly vital in this situation. So there's a couple of things that's important here, right? So there's some things that airline is not good for, and I think one of them is for things that are things that require highly intensive calculations and things of that nature. Um, so there's something that airline is not good for, that people would say is probably not good for. So numbers that are highly exponential is something that airline is not geared to, from my understanding of things. Um, so how do we solve that problem, right? How do we solve this issue? And I think that when we consider that, we can look at the design of the system in a multitude of different ways and fashions. I think that with process oriented development, right, what we want to do, we want to orchestrate correctly the the information, not only the data. There's been some interesting talks on this today. Not only the data that we want to orchestrate, but we also want to orchestrate the processing, right? And I think that one of the most powerful things, although there's no official ORM on Erlang for Postgres, which I find quite bizarre, but I'm still exploring. So, and then still digging deeper into the language. I'm still quite new to it in a sense, so I'll probably get a deeper insight, a better understanding at a later date, or maybe find something. But I believe, or at least I think, that utilizing other systems to offload these calculations is one of the most powerful things that we can do in Erlang. So, for example, Postgres has the ability to work with timescale, which is a Postgres extension that basically updates Postgres to become a time series database. So while Erlang might not be suited to that type of information, it's highly possible to perform those calculations on or offload from Erlang those particular calculations to Postgres, because you can do quite dynamic things with the actual Postgres syntax or SQL syntax within Postgres. So you can have that data and then use Postgres in a low latency environment in terms of networking, and have it actually have SSDs on your Postgres database, and have it actually perform specific calculations and operations on that particular data, and you just take that information wherein it's not majorly exponential anymore, um, and utilize it within Erlang, right? So for example, analyzing time series information, you can have that within Postgres, and just run that calculation against Postgres, and get that information into your Erlang system, and perform that particular task within a particular process, or perform particular decisions geared towards that. And also there's ZomboDB, which is something that enables you to have full text search. So you can do fuzzy search within Postgres, but it's not as effective as most people would like. So ZomboDB would be an ideal thing, because it allows you to embed Postgres. It allows you to have Postgres fields within it allows you to have Elasticsearch fields within Postgres, so you can search more effectively. And so Elasticsearch is there as a text search system that you can utilize in order to actually perform varying lookups very, very easily, and more effectively in a sense, especially around the text and things of that nature. And there's a bunch of different reasons why you might not want access to that, right? Via Elasticsearch, multitude of reasons, depending on whatever information that you may have to sort of go through, depending on your application's use case. But I think taking those processes and having that ideology is very important. So you can actually have different processes registered within Erlang, designed through OTP, handle call, etc., start, stop, link, spawn, many processes, etc., that are running within Erlang, that provide interfaces into making these calls and accessing this information within these remote databases. Because you can't do time series analysis within Postgres, within Erlang, that great, and it's not that fast at that. Text search, yeah, you could do within Erlang, but again, the storage of information is probably better off or information that might be in progress, Postgres that come from different sources. Having the ability to look through that, um, whether it be some type of time series data, whatever it could be. Um, it could be nearly enough anything depending on a particular use case, but there will be use cases where you want to search through text and things of that nature. And then you have Neo4j or just any other graph database where you want to perform other types of operations, right? That are not suitable within Erlang. Although there's diagraph within Erlang, which is important as well. Take note of that. And then also, but just having that ability to do these other complex calculations and these other applications is vital. And it reduces the complexity and the requirement of what may be limited within Erlang itself. So yes, I think that's definitely very powerful. And then again you have Redis that can act as a cache, not only between these systems, but it can help reduce latency and things of that nature. So the actual way the program itself will be designed is quite drastic and quite different for each particular use case. However, some of those things that Erlang is not good for can be offloaded. So even Postgres, you can do machine learning on Postgres databases, because Postgres actually has the ability to write functions. So you can actually write functions that run on the Postgres database. So basically, this is just distributing processing load from Erlang or the Erlang nodes into other systems as well that can better handle that process. That can utilize some of the type of library or function to perform whatever it is that's required. Whatever evaluation is required. So Postgres has the ability to have functions written in a multitude of languages that can then be run and used against the particular data that's available to that particular database itself. So that's pretty much that, really. So we can think about that as the right brain, left brain. The sort of the analytical side of the brain. Right brain and left brain. If you take that into consideration, you can think about the analytical side of the brain, right? These databases can be used for that. And then what we do is we bring that data, that information into Erlang. And then you got things such as ETS, you got things such as deets, and you got things such as Mnesia within Erlang itself, in the Erlang programming language, right? So these are things that are available in the Beam, and you have also diagraph and things of that nature. So they can actually perform those calculations and those operations on the system. So you take that information from these databases and you use these things as caches. So ETS is a cache. Mnesia is in memory and can also be stored on disk as well. So they can also be made persistent. Deets is I think it's disk based storage. I'm not too sure exactly what it stands for. Basically, it's more so on the file system. So if you have SSD, that can definitely improve it. So what you can do is you can actually design. So as the left side of the brain is more creative, what you do is you take that information from these databases, you go back and forth, and actually what I mean is design the queries specifically to perform calculations on this data, to actually perform operations on this data, and offload some of the more intensive exponential calculations to those databases, and then have those ideally in a low latency environment wherein the information comes back to Erlang to be utilized creatively, and so the results themselves can actually be stored in ETS, and in deeds, and anything that's requiring persistency in amnesia, which I think believe means memory. And then also, Redis, you can use Redis as a level 3 cache, wherein the rest of the information that might need to be removed in order to make room for new information within the Erlang temp storage, the in-memory storage, can be stored within Redis before it's actually, either stored in a database or removed entirely. So I think that's one of the key things there. I think that there was a talk today about an RAM called Active Record, but I think that's only available in Elixir at the moment. However, I believe this is an effective methodology overall that enables the Erlang system to provide effectively for all, if not most, use cases to serve in the cybernetic process. So again, just as I was going over before, Postgres is a powerful system with many extensions, including many functions that can be written for it. So having that provide for some of those analytical things, including also geo spatial data, can be analyzed within Postgres. Like, Postgres is amazing, right? Like, who doesn't like Postgres? It's amazing, right? And so taking full advantage of that is really key. And Neo4j as well, as a graph databases, running particular queries is important, which Erlang might not be able to handle. In essence, and also, Elasticsearch being able to perform different types of searches, so not just only on text data, but Elasticsearch is more than just a text search. I believe there's definitely a lot of things that can be done with it. So Erlang having access to that is key, and also utilizing different types of storage systems within that are natively available within the Beam is vital. So I hope you can see my thinking processes around this. So having Deets as a disk term storage. So I understand that there's always been that discussion within the Erlang community about whether or not we require a database or just use the file store, right, on the system. So Deets is very good for that. Erlang temp storage is good for in-memory usage, and Amnesia is good for also in memory, but also on disk, as far as I understand, and it gives you a sort of query language as well to that data, and can be made distributed, right? So having the distribution as well between different types of nodes, so this can really help just like how you design things, how you implement things, and how you ensure that everything sort of functions as intended. Is vital and key. And obviously, I was gonna make this talk about way shorter than this. I was hoping around 15, maximum 20 minutes. But again, I think that because as I'm recording it, I just take a little bit longer to express my thought patterns around some of these tools and technologies. But yeah, so offload those calculations that Erlang is not suitable for to other databases, and import that data and that information into Erlang and store it appropriately based on its use cases, and then have those processes designed in a particular way from a systems thinking perspective that favors the cyberneticians' endeavors. These some drastic things that Cybernetics provides that it can benefit from actual Erlang. And it's not to say that you can't do it in any other languages, but Erlang has the set of processes, the set of like OTP and things of that nature. There's a set of libraries available to us it has a set of procedures and functions that are fully built into it to provide that effectively, to provide what's required in an effective fashion, in an effective notion, is in my understanding, in my understanding of things. And so that's the same as the right brain, left brain, wherein the left brain, which I believe is a creative aspect, would actually make use of the information that will be offloaded to the right brain, which is the more analytical side. So where the databases will be, and take that information inwards and actually build from that. And you can have and you can have different types of values and things that are stored in a particular way on the actual system itself within ETS, amnesia, and deeds. You can have a way to actually define the files themselves in a particular order using a particular schema to actually expand upon, because there's a limit to how big the files can be when using deets. But then again, at the same time, you can have the files themselves actually organized in a particular way on the disk that enables you to perform interesting lookups and have more information stored within memory, that can then enable you to do more interesting and dynamic things. And not only that, but just it enables you to have that information available to most processes from in memory, which increases the speed of things, which is drastically important and vital. And basically, that's pretty much it, really. And I hope that really encompasses, because this was intended to be a lightning talk, but then again, at the same time, I hope that this sort of encompasses most of what's actually relevant here, in a sense. So yeah, so I think that's pretty good. And after this, I think that you become more free to understand how to utilize Erlang, and not only just Erlang but the beam itself. And you can feel liberated, right? That those limitations aren't really there. Um, and I think I didn't cover, like, there's other things to use, like drivers and nifs and things of that nature, but that's beyond the general scope at the moment. Yeah, I think the concept is just sort of understanding the liberation that can be provided, and how the functional nature of Erlang and OTP, and some of the functions provided by OTP enable individuals. Yeah, how that enables individuals to actually scale, um but also, yeah, not only just to scale, but also enables individuals to design systems without limitation, which is fundamentally key. And you can design systems that are geared towards the cybernetic way of thinking, that are geared towards cybernetic, or at least previously thought of cybernetic technology, in a new fashion and in a new environment, in a sense, which is key and vital to everything. So yeah, so if you have any questions, please feel free to put those in the comments. And yeah, and you can email me, reach me at Twitter. You can follow me on Instagram as well if you want. But yeah, there's not really much there, and I tend to just go off the bat. But yeah, I'm always interested to share ideas, and you can email me as well. No, I'm not email there, but you can email me at David at o3h.re. So that's o3h.re. Again, I hope you enjoyed that talk, and I hope it brought some insights and some thoughts around how you can design and work with Erlang without any limitations. Thank you for watching. Thanks for listening. Take care. Bye.